this we will have a small experimental setup. Okay, so this is the experimental setup we have. Okay, what we do, children, we take two troughs. Okay, two troughs. These are the two troughs, children. Okay, these are the troughs. And in these troughs, we take water, fill this with water, and then we take a small watch glass, children. This is the tiny watch glass, okay, on which we take some phosphorus, and this watch glass is allowed to float on water with help of some cork or some lighter material, okay, and then we invert this watch glass with a bell jar. Okay, with a bell jar. And this bell jar, if you see, children, it is graduated, that is, it has markings on it, right? Now we are going to pour water such that the water comes up to the 0 mark of the bell jar. Okay, and then what we do is, children, we slowly remove this lid of the bell jar and we ignite this phosphorus. When we ignite this phosphorus starts burning. So basically, children, after some time, we see, after the phosphorus has burnt, we see that the water level in the bell jar has risen up to the mark 1. Okay, so what is this that has caused water in the bell jar to rise from the 0 mark to mark 1? Okay, now basically phosphorus, okay, phosphorus reacts with oxygen present in this air to form phosphorus pentoxide. Okay, so phosphorus burns in air, okay, and combines with oxygen to form phosphorus pentoxide, and this phosphorus pentoxide can combine with water to give you phosphoric acid. So this particular oxide, that is phosphorus pentoxide, since it is dissolving in water to give you an acid, it is also known as an acidic oxide. Okay, so now coming back to our experiment, children, we have seen that the water has risen up to mark 1. So this is because the oxygen part of the air was consumed by phosphorus to convert itself to phosphorus pentoxide. So because of the oxygen being consumed, a low pressure is created, and because of that, the water rises up in the bell jar up to mark 1. This shows that out of the 5 parts, 1 part of it was consumed, and that 1 part which is consumed constitutes the 1/5 of the air, that is the active component of air, which is nothing but oxygen. So this shows that 1/5 of the oxygen is the active component of the air, which is oxygen, and 4/5 of the air is the inactive component of the air, which is nitrogen. Is that clear, children? So from this experiment, we have proved that 1/5 of the air is the active component oxygen and 4/5 of the air is the inactive component nitrogen. But in the composition of the air, we have also discussed that air has other components like carbon dioxide, water vapor, etc. Yeah. So now we are going to show that through an experiment, we are going to show that air contains carbon dioxide. For this, we need to take a test tube, a glass test tube, and fill it with lime water. Okay, and then we are going to fit this with a 2-hole rubber cork. Okay, and through one hole we insert a delivery tube such that the delivery tube immerses itself in the lime water. Through the other hole, we insert another delivery tube, which is above, the end of which is above the lime water. Then we suck air through this particular tube. So when we suck out air through this, a low pressure region is created here, and then the air from outside will enter through the first tube. So let us say this is tube A and this is tube B. So when we are sucking out air through tube B, the air will enter through tube A and it will enter the lime water, and this lime water will turn milky. Okay, it will turn milky. This is a test for carbon dioxide, children. Lime water turns milky. So this shows that apart from nitrogen and oxygen, air also contains carbon dioxide. Now let us see how we prove that air contains water vapor. Okay, so for this, let us take a glass, wipe it clean and dry from the outer side so that there are no water, any sort of moisture or water, and then we fill this glass with ice cubes. Okay, and we place this glass outside. Okay, so after some time we see that there are fine droplets on the outer side of the glass. Now, where have these water droplets come from? Okay, the moisture, that is the water vapor present in the air, has, when it comes in contact with the cool outer surface of the glass, will condense to form the water droplets. So this formation of the water droplets shows that air has water vapor, and this water vapor has condensed when it came in contact with the cool outer surfaces of the glass, and it has formed water. Is that clear, children? So by this experiment we can prove that air also contains, okay, air also contains water vapor, which is again variable, children. Okay, the content of water vapor may be 0.4 to 4% also, depending upon the temperature and so many things. Is that clear, children?